Cool. Look good. Making sure I get all my windows in the right place. You'll have to let me know how the animations go as well. I don't know if my bandwidth can take it. But yeah, so let's get going. So this talk, well, it's kind of three talks in one, really. DDD, CQRS, and onion architecture. So there's three kind of hopefully clearer sections. And the first word of warning to go with it, there are lots of arrows in this talk, and they don't really mean anything in particular. They mean dependency or contract knowledge, kind of like this bit knows of that bit. Doesn't really, there's no like UML notation or anything like that. Yeah, I'm sort of making them up as I go along. So don't try and hold me to which arrows mean what. And what's happening, we're going to do the section. So 20 odd minutes of arrows and boxes and shapes and architecture stuff. There's your onions. And then I'm going to start building that architecture up from the middle. So the domain layer, and I'm going to talk about DDD for a quarter of an hour. And then the layer outside that, I'm going to talk about CQRS for another quarter of an hour. And then roughly 10 minutes on tying it all together, infrastructure stuff, microservices. And there are tons of amazing animations like you saw there. Big statement to start with then, I think. Software is about drawing boxes. Not to diminish anybody's long and hard working career. I've done this a fair while, and it pretty much all comes down to drawing boxes, where you want to define a certain boundary, or at least the design is. And here I've got 4 boxes, 4 methods. I've decided to put things that I think are related within these methods. And then I can draw more boxes around those. Maybe I put 2 of these methods in a class because I feel like they're related. And I might say that method B, for example, is private or internal to that class, whereas method A is public and on the outside. And I might draw another box around both of those, and I'll call it a class library. And then again, I can say class B is internal and can only be accessed from inside, and maybe another one's public. And then I can draw another one of those. I can draw an API. This is the same thing, except I've given this one a bit of meaning, and the library I've said is an API library, and my classes, I'm going to say they're controllers, and the methods in there are called actions. So it's all about defining boundaries. You can draw a big box around all of that as well, if you like. You can call it a component or a solution, service. So software is about drawing all these boxes and arrows. I said there'd be arrows. So here's an arrow. We've got a dependency from the API library into the other library. Call it the business logic. You can draw another arrow. Love between classes. This class knows of that. Remember, it's just about knowing. It's not about anything, no UML or anything. We like to personify these boxes. We say this is allowed to know this knows that, but this doesn't know that it's being called by that. We give it a bit of a personality. Then we can try and do that, but we're not allowed to do that because that would create a circular reference. In this exact example, if I tried to make in a .NET project, an API project, reference this library while this library also references that, you get a compiler error, circular reference. You're not allowed to do that. You could do that between your classes, but you might have some code quality tools shout at you saying you've got some high coupling. Similar with methods. I suppose the lower you go, there are valid reasons to do that, like recursive methods, but generally the higher up you go, the less high coupling you want, the less circular dependencies you want. So you might be familiar with these boxes and these arrows. This is pretty common. This is an N-tier application, this kind of architecture where you've got, usually it's called N-tier, but there's usually 3. Your presentation layer, your business logic, and your data access layer, and one depends on the other. So this black arrow here, I'm going to say means depend. Like the data access layer doesn't know of the business logic layer. It's the business logic layer that knows. Like it can say add this to the database, but the data access layer doesn't know what the logic is. And I'm going to throw this other arrow in there. This is, now why have I done that? I've just thrown another different colored arrow that goes across the whole thing. There is some method to it. This is the flow of control, which is certainly different from the dependency. The flow of control is about who's driving, who's telling who what to do. So it's not about who knows, who the dependency is, who knows of what. Flow of control is who tells it what to do, who drives. So for example, if I put a breakpoint in at my data access layer, and then I looked up the call stack, I'd be able to see that that was being called by the business logic layer, and I'd be able to see that that was being called by the presentation layer. So it's like the method calls, the flow of control. I keep doing this with my hands, and I know that on video, everything is reversed, isn't it? So I'm going like, this arrow here on the right, but actually it's the left. Did you see that? Did you see that arrow flip itself round? I've drawn another arrow in there. Not the new arrow that's just appeared, but the arrow that the new arrow was pointing at is now pointing the wrong way. The dependency is going the wrong way. The flow of control is still going one way. So let's have a look at that. That's dependency inversion. So before we go into why you'd want to do that, how have I done that? So I've added an interface. Remember, it's not UML arrows. So these arrows, you'd have, let's say this interface is your I repository, and I've got repository implementation on the right-hand side, and the service is calling the interface. So both arrows, they both mean know of in this diagram, but in UML, one will be like this implements that, and one of them will be this uses that. But they know of that. You're probably used to seeing your I repository interface over here in the data access layer. And when it's over there, you can see the black arrow, the dependency. The service obviously knows of that interface, and my business logic layer needs to reference the data access layer. But by moving it over here, all I've done is move the one interface. By moving it there, I've changed which arrow is kind of exposed outside those blue boxes, and now the direction of dependency has changed. And we try to demonstrate that another way. So here now we've finally got some code. We've got three classes: the service, the interface, the talk repository. It's a talk about a talk now. It's talk. And then you've got your entity framework talk repository. So your implementation of that repository, which I'm going to go and call into entity frameworks DB context. Now, if you look at the top, I've drawn the boxes around those two for the business logic layer. But all I've done, well, you're probably used to seeing, if you draw the boxes there, none of the code has changed, but I've exposed a different arrow there. So now the dependency is going the same way as the flow of control. All you do is draw the boxes in a different place, and suddenly the arrow, you've inverted the dependency. The one that's exposed outside of these project boundaries is pointing a different way. So that's how you invert the flow, well, invert the dependency or invert the control, whichever way you look at it. This is in this architecture with business logic and data access. These are ports and adapters. So this is, you can imagine this port, the way I like to see it, the port is the interface, the iTalk repository, combined with the talk entity object. And it kind of says, the business logic is saying, well, I know how to use this. I don't know how to implement it. So anybody that knows how to implement this, please depend on me, reference this project and implement it yourself. So it's declaring anybody that can plug into this. And the metaphor there is the electrical devices. You can imagine like a plug socket. So anybody that can plug into this can get some electricity. Your adapter there on the other side is then going to reference that, and adapter is going to encapsulate, is going to implement that interface and probably encapsulate another one, like my example, which encapsulated entity framework. That's the gang of four adapter pattern. So there you go, there goes the name. But it's got the same electrical devices metaphor. You can, like, if you go into Europe, you have a different plug socket. So you'd have an adapter, and an interface, it implements one interface and encapsulates another. This is, so I've drawn on the right-hand side, this side, my left, the database technologies there. I've drawn it in gray because it's not in my control, but you can see there, my adapter can be whatever I like. Entity framework was my example. You might want to use MongoDB, maybe use Dapper, whatever your data technology for your I repository. In this case, you adapt it, whatever. The business logic layer has no idea what kind of data technology is behind it. The business logic layer, whilst it still calls into it, the yellow arrow, the flow of control, it's still calling that I repository, but there's not even a transitive reference over to my data technology, over to entity framework or something like that. The black arrows don't follow all the way through. So I couldn't even use entity framework, for example, the primary key attributes or any of the data annotations that you get. I couldn't even put them on that talk entity, even if I tried, because there isn't even a reference going through to entity framework. Couldn't even accidentally use it. Entity framework, as in that example, has a way around that. It has the Fluent API, it's called, that you can put in your DB context implementation. You can reference within your data access layer. You can say this property is the primary key, and this, you add annotations in a different way without the attributes, so you don't need the reference. And if we look at the other side, now this is basically the same thing. Look at this one there again, the one that the new arrow is pointing at. This is my controller has to have a reference to MVC. Like you've got your HTTP get attributes. You've got the controller base class, but you've just got the general fact that it's a controller. It knows how to implement this MVC framework. The MVC framework doesn't know of my controller. My controller and my presentation layer knows of MVC. So in a way, you've got an adapter here as well. But the flow of control still remains all the way from MVC over to the database. Again, if I put my breakpoint in at the data access layer, followed the call stack up, it'll be business logic layer presentation, and it would be ASP.NET MVC that's calling into my presentation layer. That's controlling my controller. Hey, maybe that's why it's called a controller. And then it follows all the way down. But the dependencies are inverted. So look at the middle there, the business logic. There are no arrows leading out of the business logic layer. It doesn't depend on anything at all. Things depend on it, but it itself is a pure, just a class library. It's got no external dependencies. There's no network involved here. It'll be very easy to write some unit tests around this logic because there's no database you got to mock out. It's just C# or Java or whatever your weapon of choice is. So putting that business logic in the middle, it's core, it's pure, there's no dependencies. This is the ports and adapters architecture. And here's one I liberated from the internet, a diagram. One problem with this diagram, not enough arrows. The API layer at the top you can see, and the same as my database layer at the top right, they're the ones I had on the diagram before. But now we've got a sort of two-dimensional, we've got hexagon in the middle, we've got a message queue and a console, we've got more adapters. So it's more adapters. It's the same idea, but the two-dimensional idea with this means there's room for more adapters. It's not a linear N-tier style thing. You can have as many adapters as you like. And we have the flow of control. The headings at the top there, primary or driving adapter. This is about the flow of control here. So my API makes a call in to my business logic. So it's a driving adapter. It's the one doing the driving or a primary adapter. These terms are interchangeable. And on the right-hand side, we have the secondary or driven adapters. So they're being driven by, so again, they've got the inverted control. The business logic is calling them on the right-hand side. This is called the hexagonal architecture. Originally, this was Alistair Cockburn in 2005 came up with this sort of idea. This got nothing to do with the number 6. This is purely a visual cue. We like shapes. We like ways of visualizing things. Again, he said himself, it's about making it two-dimensional and leaving room for other ports and other adapters, but it's about shapes. We like these structures. Here's a N-tier or layered architecture diagram, again, stolen from the internet. It's visual. We've got these colors involved. We've got the different tiers here. We've got different layers. We've got arrows, very visual. I had a go myself. I used to make most of these projects in this kind of architecture. Olympic rings, you had dependencies going downwards, if I can call that going downwards. You had flow of control going left to right, same as. I thought I was being pretty clever here with 5 C# projects, and there's the dependencies, and it was all very, very clean. But actually, if I just did that and made data access and entities the same project, I've got myself an N-tier architecture here. This is just presentation, business logic, and data access layers. It's just the same. And if I did that, so made the 3 in the middle one project, I've got myself ports and adapters. So I thought I was being really, really clever, but I'd actually just reinvented 2 wheels. This one's a cone. We like shapes. We like the cone. The cone is actually a slice, like a pizza slice of this circle. The clean architecture. What's wrong with this diagram? Not enough arrows. The clean architecture was Uncle Bob Martin. This is the onion architecture. That's what we're going to talk about today. We finally got there. We are on one of the title pieces. This is the onion architecture. This is clean architecture. I keep flicking between them. Very similar concepts. They're a circle, and all the dependencies point to the middle. The clean architecture here, actually, in Bob Martin's post, references the onion architecture. It says it draws from those same principles as hexagonal and ports and adapters architecture, where dependencies go towards the middle here, and you've inverted the infrastructure, inverted the flow control in the infrastructure. You'll notice the clean architecture has all the frameworks and drivers on the outside, which onion architecture doesn't. but they both share that same circle shape where things go into the middle. And again, we like that onion. It doesn't have to be called an onion, does it? But we like that metaphor. We like the fact that it feels like you can peel away these layers. You can peel away the presentation layer, and there's a application layer underneath it. You can peel away that application layer, and then there's a domain layer. Like, it's nice. It's a nice way of visualizing it. But it doesn't have to be a circle. It doesn't have to be an onion. And to prove that, I invented the castle architecture. It's exactly the same thing. The code is exactly the same. I've just drawn the diagram like a castle instead of a vegetable. It's exactly the same thing. I really did try to get like all the animations to all land exactly in the same shape, but the arrows and the boxes and the colors are all exactly the same here. You wouldn't even have to change the code to implement castle architecture. You can have as many merlons as you like on the top as well. It's not limited to 3. So am I just saying that onion architecture is hexagonal architecture, but with a domain in the middle and an application layer referencing that? Yeah, basically that is it. Hexagonal architecture had this application core in the middle, and onion architecture expands on that and divides it further into layers. Not necessarily just application and domain. There's many layers you want. The fundamental principle is dependencies go inwards from that layer, and it just divides up that application core's logic. And that's all I've got on like shapes and boxes and arrows. If there are any questions on that before I'm now going to start building it up. So I'll start from the domain layer and I'll start building up DDD and bits. No questions on that? Cool. Domain layer then. Domain layer. So I'm going to build the domain layer in DDD. You don't have to. It's not a requirement of onion architecture. It says there will be a core domain in the middle. DDD seems to fit really nicely with that, but it's not a requirement. Let's have a look at what's in this red circle then. Domain-driven design we're going to find more boxes in here. What we're going to find in the red circle, we're going to find aggregate roots. Oh, we might have heard of them. Entities, there's a few of them in there. Yeah. We're going to find domain events. Yeah, and value objects. Stop! Like the first few times I've done this, I've really shouted that bit as well. But I had some feedback that I probably shouldn't.
Did anybody shout in the name of love?
I went for hammer time.
Oh, I need somebody.
Oh, better.
See, when you were going through all those things, I really wanted to shout bingo.
Yeah. Love it.
I know I've stopped the shapes, but that's an octagon as well. That's sort of irrelevant fact. I thought I'd say that. But yeah, this is the biggest mistake everybody makes with DDD, or I've made it. I've seen many other people make it as well, where you get sort of obsessed with the technical details. We're engineers at the end of the day. This is a architecture talk, and I want to talk about the architectural pieces, but domain-driven design actually isn't about that. It's a business first thing, and it centers around the domain model in the middle. Domain-driven design really just says that the structure and the language of the code should match the business domain. That's from the Blue Book. Centers around this domain model in the middle. So we're not going to, well, if it's matching the business domain, we're not going to talk about HTTP clients and whatever providers. We're not actually going to use these technical terms. It's ironically not about aggregate roots or anything like that. It's ironically about not using technical language like that. And then it comes with all this technical language. But it's about a collaboration between the technical experts, that's us, the software developers, the engineers, and the domain experts. They wouldn't be technical. They would be, for example, I was building a payment gateway, and the domain experts there are the finance team. They understand how payments work far better than I do. So between us, we build a ubiquitous language. This is one of these terms. So you agree a language, you can build yourself a glossary of this language, but you define the terms that you're going to use, and you should use this language everywhere. You should use it in your stand-ups, use it in your requirements. The domain experts should agree to talk to each other in that language, and the software engineers should agree to talk to each other and write that language in the code. That is the language that is ubiquitous. We're all going to use the same language. And I was watching a Scott Voloshin talk back in years ago now, the last NDC in person, that it was in F sharp, but he had this domain and it was in F sharp, but he said he'd written out this domain code, and then he gave it to the domain expert who wasn't technical, and they said, yeah, great, that's how I understand the domain, that's the model, where's the code? And I really liked that example because it sort of gives you something to strive for. The domain experts should be reviewing our PRs because it's written in their language. They should understand this domain. I know in C# you're going to have some keywords, you're going to have public, it's going to be class, but yeah, that's something to strive for. Now there's a whole culture around domain-driven design, which I'm not going to go too much into. It's a talk in itself, really, but you got to get the business on board. That language develops over time, the model develops over time. You would have a two-way relationship. So if your unit tests, for example, find out that there's a bit of a flaw in the language or a flaw in the model, you might want to revise the model, maybe just a slight bit, or maybe you introduce a new term for some kind of abstraction that you need in the software. You need the business experts, the domain experts, to then agree to use that language when they're talking to each other as well. And they can sort of battle test it in their language when they're actually working in the domain. There's a whole culture around that, which not ironically, well, I'm going to go into the technical bits, the exact bit that I said you shouldn't do first, that you need to stop and you should do the cultural bits first. I'm not going to talk too much about the cultural bits. I'm going to do those 4 little boxes that we saw in the circle. So domain events. Domain events are something that's happened in the domain, something that the domain expert would be interested in, something that they, it's usually a change of state. It's usually like an object has changed from one state to another, so an event is raised. And some examples in C#, we've got an account was registered, an account registered event, payment made event, talk started event. These are different domains with different domain events that you could have. You don't have to use exactly the way I've implemented it. I've used a iDomain event interface here. Notice I've used it init only properties here because these events are immutable. They cannot change. Once you've created this event, the state cannot change. You can't go in and just go back and change one of these properties. Once the talk has started, you can't go back and change who the speaker was as much as you might like to at this point. It's mutable because it's an event. It's happened in the past. It's already happened. Notice the wording of them: payment made, talk started. It's past tense. They're events. They've already happened. A good way to learn these is a process called event storming, but there's a few similar processes. There's one called domain storytelling. I don't know which ones I've tried. They all sound quite similar to me, but yeah, you just get your domain experts to tell a story. And you'll notice you just say, what happens in your domain? How does it work? And then the finance experts will say, yeah. And then somebody makes a payment and you can write that down. Like, yeah, there's your language, make a payment. And then that's a payment made. The payment was made. And then other things happen as they're telling this story. And they're your events. That's event storming. And you can contribute back. You can ask some questions about the properties on the event, maybe. So yeah, tell a story. That's a bit of a cultural thing that I said I wouldn't go into. So I'm going to try like a sequence-ish diagram. It's so the red circle on the side, remember, was the domain. I was going to call it the flag of Japan architecture. It's just a red circle on a white background. That's the domain on the side. And I'm going to say from the outside, we say do a thing. And that's going to go into the domain. You'll see what I mean by a sequence-ish diagram now. You've got something on the outside of the domain says do a thing. And that's our flow of control, remember. See, there is a little bit of meaning into the arrows. And then it depends on the domain as well. The domain has defined the thing, what the thing is. This might be a method call into one of the domain objects. From outside the domain, you say, do a thing. So the domain goes up and does a thing. And then it says, something's happened. That's the domain event. And it publishes the domain event. Just to anybody who's listening, you can imagine it shouting out, just going, yep, something has happened. Anybody who cares. Because the domain doesn't know who's listening. It's just publishing it to 0 or many subscribers. The subscribers have came along previously and said, when something happens, I want to know about it. And when they did that, they knew the something happened event existed. So they know of the domain. So they depend on the domain. But the flow of control is coming out with the publish. So here again, I've inverted the flow of control. So domain events or any events, a publish subscribe pattern is a way of inverting the flow of control, just like our ports and adapters architecture. Entities and value objects. I'm going to whiz through these ones. So these are, you're either one or the other, and these are the sort of nouns you're going to find in your domain. So value objects, they have structural equality. They are what they are. So examples could be like your account details on a bank, or your address, or your postcode. These are, if you said, are these the same, and they have all the same values, then yes, they are the same. They have structural equality. Whereas entities have identity equality. They have their own identity. So if you had a person object and you had hair color, two hairstyles and the same hair color, but they might not be the same person still, just because they've got the same hairstyle. So they have different identities. Even if all of their properties are exactly the same, they are still a different instance of this thing. It's kind of similar to a struct and a class. It's not quite the same, but it is quite similar. If you can understand that, like the value equality, it is what it is, or structural equality, identity, doesn't matter if they're exactly the same. They have an ID field. They usually come with an ID field. So entities are mutable. You can change them. Value objects are immutable. You can't change them because they are what they are. You can't just say all red is now blue. No, red is red. So value objects have no lifespan. Entities have a whole history. As they change, they have a history over time. And then aggregates, these are a cluster of several entities and value objects. So a cluster of domain objects. And I stole this one from a great Medium post by Chen with a car example, which I think is a good example. Inside the car, you've got an engine, which in this domain in my head, I would say is an entity. You can have two of the same type of engine. They might have all of the exact same properties. You can have two, I don't know cars, but V8s. You can have two V8s. And you can say, are these the same engine? No, they're not. They're not equal because they're not the same instance of the engine, even though if they're exactly the same type. Same with the door. You can have all different types of doors. You can have those ones that open sideways. You have different kinds of lights. You can have those horrible yellow ones. Wheels, mirrors, these are all entities. But then color, depending on the domain, I would say that's a value object. Because if a car is red, and I was going, if red equals red, I would expect it to say, yes, red is red. They are the same color. A color is identified by its value. So it's a value object in this domain. There may be domains where it's not. There may be domains where these entities, examples that I've given, may end up being value objects. And then the car itself is an entity. It's another box. And we draw it around all of these boxes and we say, this is the aggregate as a whole, all of these together. So these 7 objects are the aggregate of a car. And the car, that provides a consistency boundary. So it means, again, with the drawing boxes, it means from the outside of the car, we can only talk to the car. We can't talk to an individual wheel. If you were driving a car, you would say, I want to turn left, but I turn the car left. I act on the car aggregate. I don't act on individual wheels at the time. The system does that. I just act on the car. It's like my way in to all of these different components is my aggregate route, the car entity. So if I was to show that with some code, here we go, some more code. This is my implementation of a car aggregate route, which is an entity, and I don't have to use exactly this implementation. So I've gone with an entity base class. So it says my car is an entity, but it's also an iAggregate route interface, which in this is just a marker interface. It doesn't require me to implement any properties or anything. And I've omitted the constructor and some properties. You've got the engine there. You've got an enumerable of lights. And then you've got the body color as a property. But note that it's a private setter. You can't just go and set the body color. And below, I've got a paint body method. I'm using my ubiquitous language. It's not set color, because if my domain experts that work in cars, they're not going to be talking about set color. They're going to say paint the body. And in that method, I've got some domain logic. So I can ensure that the color is not yellow because we don't like yellow cars. I can ensure that there's no lights already installed on the car, because if you're going to go and paint the body with the lights on, then you go and paint the lights. So we say that's business logic. You're not allowed to do that. And then once I've passed all the validation, body color equals color. So I'm setting the actual property with my private setter. And then I'm adding a domain event to a collection. That domain events collection there is from the entity base class, but it's just a collection. I think important thing to note here is it's not actually publishing this at this point in time. It's adding an event to a collection, which is just sitting in memory in this car aggregate. But that's my body painted event. That's a domain event. And then I can add some other properties to that. I'll put what color it is or anything that I need on the event as a property on there. And then I'll probably find the data abstractions. Now, this is a mistake I've made. And to be honest, I think people still sort of and ah about where these should live if you're being strict on layers. Now, they're often seen in the domain layer, but they sound quite technical. You wouldn't expect your domain experts to be talking about repositories and units of work. But these are just abstractions. So this isn't the actual database stuff. This is like a port. I mean, in ports and adapters, this is the iRepository is just a abstract thing where you can put stuff. And it doesn't know that it's a database, it's a port, and it says anybody that knows how to implement repositories, please do. And the layers above will say, yes, I know how to do repositories with databases. And the unit of work is an abstraction around a database transaction. So I can make loads of changes to stuff in repositories. I can go and add loads of things. I can remove them. I can update them. You might want an update method as well. You don't have to use exactly these signatures, by the way. Like your IDs might not be GUIDs. You might use integers. You might want to use async adds if they're actually going. You might want to use non-async commit, or maybe you don't want the async suffix, whatever you like. Your unit of work is the atomic operation, the transaction that you're going to commit to that. So it's like an abstract data transaction. I can make loads of changes, but I can do loads of work, but I'm only going to commit that and save it to a database as one unit, as one atomic operation. That's my unit of work that I'm going to commit. But these are just abstractions. And what I'm talking about this in the domain layer, the DDD section of this, and you will find these in DDD, but I kind of like to see them as just on the outside of the domain layer. Because I wouldn't expect my aggregates to know what a repository is. Sometimes we put this in the application layer because we've kind of assumed this is an application concern, but it's part of DDD. So it's kind of somewhere in between, I think. Remember, onion architecture doesn't define that there has to be a domain or an application layer. You can have as many as you want. You might not even decide to represent these layers as a separate C# project, but as long as you're viewing it as dependencies go inwards, repositories sit on a little slither, a small layer outside of the domain. That's the way I like to see it anyway. And that, Pete, is my halfway point, I think, before I would then go on to the outside of the domain layer, but this is probably a good pause if we wanted a break. So if you remember, we had these two layers. I'm going to build the outside of that. I'm going to build the application layer. You can see it all right, yeah. The application layer. So onion architecture dependencies go inwards. So my application layer is going to be the thing outside of my repositories and my domain layer that's going to be talking to those aggregates, those domain objects that I've mentioned. It's going to be the thing that's on the outside saying do the thing, and it's going to be the thing that might be listening to my domain events. But my domain doesn't know that it's there. So inside the application layer, what have we got? Same again. Let's see what's inside this circle. We've got command query responsibility segregation. So that's CQRS. That's how we're going to build it. Again, it's not a rule. We can use services. We can use whatever we like. For this example, I'm going to use CQRS in here. You can use CQRS on its own without onion architecture. These are three different things, but in the CQRS application layer, we've got commands and we've got queries. It was kind of in the name. But before I tell you about CQRS, this is like Greg Young came up with this, but before CQRS existed, there was CQS without the responsibility part of it, which just says every method should either read or write, but not both. And that's basically all it is. A really nice way I've heard it described is asking a question shouldn't change the answer, which is, I think it's pretty cool. Like, so if you're doing a get me this data, you can do that as many times as you like. And the act of getting that data doesn't change what data you will be getting. Otherwise you'd be violating CQS. An example of a violation of that would be dequeuing from a queue. If you have a .NET queue and you go queue.dequeue, you're getting data, but you're also changing the state of the thing you're getting data from. So if you keep on dequeuing, you're asking a question and you're getting a different answer each time. So that would be a violation of CQS. A way around that little tip, you could do a dequeue method, or like popping from a stack. You could have a method that returns void, but remember our inversion of control. You could raise an item dequeued event that you could subscribe to, and maybe many people could subscribe to that. and you can listen to that. And that's sort of little trick to get around it, and you're back in CQRS or CQS land. Anyway, CQRS is that you can only read or write, but rather than just being applied to functions or methods, it's entire subsystems. You could probably even make different class libraries, different CS proj files for your writing, your commands, and your reading, your queries. The key thing to note here, because this isn't just methods, this is entire classes, is it's not CRUD. And I find, so here's another mistake I've made. We're designing REST APIs on the top of this at our workplace. So I think it's quite intuitive when you're designing a REST API to think, when I go and post an object, or I go and put an object at a certain location, and then I go and get from that location, I half expect to get the same object back that I just put in. I don't know if HTTP says exactly that, but that's kind of what you expect. You go, put payment there, or person there, or user there, or whatever it is, whatever this object is, and then I go get it. You expect it to be the same object, and they should be the same shape, or at least have similar properties. And that is just not CQRS. All CQRS is one thing, and it's just don't do that, or you don't need to do that. These are entirely different concerns. Reading and writing, very different things. You will use different technologies for each of them, so completely segregate them. Then never need to know about each other. For commands, the way to do this is to think task-based. So I think me certainly, but I think others, I've been so used to writing CRUD that it's like ingrained. When somebody describes a business problem, I think of it as an object that I've got to go and mutate. And I think, you got to go change this property of this singular stateful object. Whereas CQRS says, well, commands should be task-based. Think about the task at hand. What properties do you need to perform that task? And don't think about an object that you've got to mutate. And it's actually more natural. I think the real world acts like that a bit more often, but we're so used to using CRUD and objects and having a database that's got something in it, and I can go get that same object back out. So the command's task-based. So I'm going to do another sequence-ish diagram where my blue on the right-hand side, my left, is the application layer. And from outside of the application layer, we're going to verb something. Verb something is what your command's going to usually look like. So any examples are take a payment, register a user. It's going to be probably going to be in your ubiquitous language. So this whole idea, I think, fits really nicely with DDD. You don't have to use it with DDD, and you don't have to use CQRS if you're using DDD. But they fit really nicely together because they've both got this task-focused, non-techie languageness about it. It's not about CRUD. It's not about mutating objects. It's just verb something, take the payment. And then inside my application layer, we're going to have a command handler. Something's going to handle that command. I'm using mediator in these examples, so it'll look exactly like this, but you might want a service that basically some kind of method that accepts that command object with the properties on it. If I was being really pure on this diagram, that handler would live in the blue circle, but then everything would be on the right hand side. So that handle method is in the application layer, and within that handle method, it's going to load the aggregate from that pinkish layer, from my repository. It's going to go to my repository and say, get me the aggregate, get me the car, get me the payment, however you split it up, and then do a thing. This could be our paint body method. We're going to call a method that's going to do some mutation on the aggregate. So that's calling into the domain layer. In onion architecture, you can jump over the layers. It's not like this layer must talk to that. So as long as it's dependency going inwards, we do a thing, and then I commit that unit of work. I say I've done with the work now. That is the work. Go and commit it. Save it to the database. And that's the sort of general. That's what a command would look like: load an aggregate, mutate an aggregate, commit the changes, and then it will return fulfillment. Now we're not going to return any business data here. We're not going to return any data. Notice I'm returning a task. It's because the command side isn't the read side. Remember, CQS, we would return void, or a task in this case. We wouldn't return an object. We're not going to get any data because we're changing things. But it is a task, so I could throw an exception and I could return an error in a way. So is that returning data because I can return an error? Well, no, the point is it's not returning business data. You're not returning your stuff that you would query, but you can return stuff about the command execution itself, because it's about the right concern, the right side, the right subsystem. So I've toyed with the idea, maybe you could even return like the number of affected rows. That might be fine. The number of affected aggregates, I suppose we'll be talking in this term, maybe not SQL rows, but yeah, stuff about the command execution. It doesn't have to be a task object with an exception for your errors. Maybe you want to return a nice little command result object that's got whether it was successful or not. Another option is it doesn't even have to be fulfillment. You could have commands that are asynchronous that return, yes, I will get around to that. It's like an acknowledgement that, yep, I've registered that command and I will do it, but it's not actually done yet. That's kind of useful if you've got a message bus underneath where you put in your command, you can return, yes, that command is on the bus, but I don't know if it's been picked up yet. So that's like an asynchronous thing. That can get a bit complicated because then you could query the state straight after and it's not actually applied yet. But the main point is not returning the read models here, just fulfillment or error. Now, if you have a look at the middle line of code there, the do a thing, we could do multiple things. We could do another thing. We could do multiple mutations within the same command. And this goes to the unit of work that I was talking about. These are committed together. From the outside, when you're looking at that blue circle boundary, I'm only seeing, I don't know what's going on inside the blue circle. So I just go verb something, do my command, and then I get fulfillment or error back. But I don't get, I did half of it. It either all happened or none of it happened. So it's one atomic operation, which is where the unit of work comes in. So if I was to do multiple things, let's say the do a thing method there succeeded and it mutated my aggregate, but then the do another thing call afterwards throws an exception. It blows up. In that case, it's not going to get to my commit unit of work. I'm going to return an error from my command, and it's as if nothing ever happened. So the first thing, whilst it did succeed, I never committed it. So it's not happened. So the command as a whole either succeeded and it all happened, or it errored and none of it happened. But there's never a state where some of it happened, because then you could get inconsistent state. Maybe next time I try to retry my command, it doesn't work that time because I've already done some of it. So that's multiple mutations. You could also dispatch the events there. So rather than doing a second mutation, I go and do a thing. Maybe I paint my car body, and then remember I said I only add it to a collection in the entity. Well, this dispatcher goes and actually publishes those. So the events come out of the domain, and then they're going to get handled by domain event handlers, which are also in your application layer. So these are now other classes, which might make other mutations to other objects, maybe even to other aggregates, but that's a bit controversial. So this is one of Jimmy Bogard's ideas. I think he came up with it, was dispatching these events before the commit. So now my event handlers, my domain event handlers, are all happening within that same unit of work. I could have thousands of things going off. I go do a thing, all of the events go out, they get handlers, maybe they make further changes that even more events then come out, and they all get handled. And then as long as everything succeeds, commit the unit of work, and it's one atomic operation. So if every command is having to dispatch and commit as like the last two lines, you probably don't want to be writing that in every single command handler. So I think it's useful to put it in a pipeline. So I use mediator. So you could say, well, for the verb something command, this is what I have to do. But then I could have a generic, like a pipeline behavior if you're using mediator or end service bus. But you can make a decorator pattern, make a little decorator, and have a generic handler that calls the inner handler and then dispatches and commits unit of work. So it becomes part of the fact that it's a command, means it goes and dispatches and then commits. Which leads me to another mistake, which is calling commands from within another command. Because you kind of see a command as like a group of functionality, a thing that we can do. So then it leads to, well, this command needs to do that command and then that command. But if you've got this pipeline set up, when the first command, the inner command, gets returned, it's going to go and commit all of the unit of work. And you've got a big problem there. You've ended up committing before your command is actually finished. So that's the technical reason not to do that if you've got this pipeline set up. But more of a, I guess non-technical or structural reason not to do that is the same reason you wouldn't call a controller from another controller in MVC. That just sounds weird, right? And it's because the command is your public contract into your application layer. It's how you talk to it. So you wouldn't want to call your own contracts, because these are the public things that I'm expecting other things to talk to. So I wouldn't call my own API from within a service. because that's what the public do. I've got access to all the domain in here. I'm just going to call my aggregates in my domain event handlers, not my own public contract. That's commands. That's like the most complicated slide. I'm glad I got that one out of the way. So queries look very similar. And this is the other subsystem. This is a whole other subsystem that doesn't even touch the commands. Queries go from the outside to go get something. It is verb something again, but these verbs are like get, read, provide. They're like, I don't know, get sounding verbs. And they'll look very similar inside. You'll have a query handler. Note that I'm returning something. I'm returning an object there instead of a task because this is a query. I am returning data and I don't want to have any side effects, but it looks very similar. And you may guess what's coming next. I just return a projection. You probably didn't see that one coming because there's no red circle. I'm not using the domain in a query because that's part of my writing subsystem. That's where I've got, like our conversation earlier about about repositories. That's where I'm using my repositories. That's where I'm saying, get me this one aggregate from the database, make some change and commit it and save it back, commit my unit of work. In the query, I'm just going straight to Mongo in this case, but you might want to use Dapper and just go straight, write a SQL query in your query handler, joining across several tables. You can use the whole point of CQRS, splitting up these subsystems, is you can use different technologies. So you could use a different database. If you find that a document DB works well for commands, but you want a relational DB for your queries, you can do it. You can have your read side use a completely different database technology. You might want a different pipeline around Mediator. Maybe your queries need some caching, but you don't want caching. Maybe you want a Redis cache that's caching your queries, but you don't want to do that in your command side because you've got these two different subsystems. Yeah, you can even read from an entirely different database. That's called a read store, which I'll come to how to create them later. But yeah, the application layer. So I just said, and all that, here's a red circle called the domain, and there's an application layer on the outside that depends on that. And then you can only use that in half of the application layer. I divided it in half and said, is that what that sounds strange? Why would I do that? So we were sort of talking about this at our workplace and going, well, can the queries not use the domain then? Well, you definitely can't return like an entity or an aggregate in one of your query projections from your query, because that means somebody could go and change it. Somebody could mutate it. And remember, queries don't want any side effects, so you don't want to be using your domain objects there. But what about value objects? Because you can't mutate them. Well, at my workplace, we kind of went, yeah, we could do that. If you've got an obvious object that's like sort code and account number as a value object, you don't want to recreate that, so use it. But I think if you're being pure, no, you don't want to use that because your projection is like a DTO, like a transfer object, but it's just full of properties. Whereas your value object's got a bit of logic in it. It might do some validation. It might have ways to make other value objects, maybe some transformations. So yeah, you probably can use value objects, but I think if you're being pure, no, you don't. But there is one reason you do need the domain in your query subsystem if you're using CQRS. And that's event sourcing. In event sourcing, you can make a domain event handler that writes those read stores that I was talking about earlier. You can have totally different databases or totally different data collections that you're writing as part of the read system. When commands change things, you can go and build up different databases that are designed for querying later. And in this model, yes, my queries depend on the domain layer, but the flow of control is still right the way across. On the left, you go, I have to do this right to left. Command makes a change to the domain, which raises a domain event, which goes and gets handled by the query side of things. The flow of control is still going there. So you can build up a sort of pre-computed table. For, I don't know, I've got an example later on stats, but that's an internal read store. So I kind of said there was domain event handlers in the application layer in both of those examples. I said there was two things, and then I gave you a third. So there's kind of three things you can do. But what can you do with domain event handlers? When you think about it, it's you can build up that read store, and there's that example that. So I'm handling my body painted event in this case, and I'm building up just a little stats database. I'm just putting the amount of paint that was used in a little stats table because later I've got a query that's going to do a sum on that. So it's just like a pre-computed, only half pre-computed, I suppose, because I'm going to sum it later. But I'm building up this database just designed for reading. It's not designed to do any logic. It's not part of my aggregate or anything like that. Build up a read store, or like I said earlier, when I'm doing commands, make further changes. So again, in this example, I'm handling the same event, the body painted event, and I'm going to go reduce the amount of paint in the paint can by that. So when the body is painted, reduce the amount in the paint can, and then maybe that's got another bit of logic or another event that comes out where the paint can is empty, which can trigger some system that goes and I buy some more paint. The example's getting a bit ridiculous now, but it's all happening within the transaction boundary, within the blue circle. All of these data changes are done before the unit of work is committed and all committed together. So there's no chance for my stats table to have had a record added to it without the body being painted, or vice versa. They're committed as one atomic operation. And on the right side, obviously the read store is part of the query side. And that's, so there are two things. There is domain event handling, but it's used in both the read and the write side for commands and queries. So they're domain events. They happen within the transaction. But then there are persisted events. Persisted events, I can write a generic domain event handler that writes every event to a similar like my stats collection, and I'm going to write it all to this one collection, which I'm going to call the event stream. So everything that happens is going to go in this one collection. It's like a history of everything that's happened in my system, event stream. All the events, I'm going to serialize them. And I've got a publish date as null there, which you'd notice. So these are persisted events. These might be different models. They might just be that your domain events can be serialized and you can put them in the database, but these are committed in the transaction. So you wouldn't get a chance of the body being painted without the event going in the database, or vice versa. They either both go in or none go in. And then later, I can query them. So it's like, again, it's a read store. My event stream is a read store. I can go, get me the events, get me the history of everything that's happened in my domain. So that's persisted events, but then you have integration events. This is like another layer on top of persisted events. In the Microsoft document, they don't talk about persisted events, but integration events. Imagine a job processor, sort of background thing that is constantly running that get events query. And then it resiliently publishes them to a bus. So it says, I've got a new event. I'm going to go and put that now on RabbitMQ, or at my workplace, we use Google PubSub, but you could use Azure Service Bus, whatever you like to publish out these events to external systems. But at this point, the transaction's already been committed. This is a background job that is querying this event stream. So you have no choice. You can't fail at this point. So if the bus is down, you can't just throw an exception and then, like with the domain events, the transaction wouldn't be committed. This has already happened. The event has already happened. The changes have already been made. Actions have probably been taken because of it. So it needs to be published to a bus. So you're going to need a retry policy. And if it still can't get to the bus, you're going to need a human intervention. So you're going to publish it to a bus, and then you're going to mark it as done. So you're going to need some kind of outbox pattern or locking mechanism here to make sure that you don't publish the events twice. You can say the events are at least once delivery, so you don't guarantee that you might get them twice. But generally, you want some kind of locking mechanism to ensure each of these go to the bus, and ideally only once. And then I'm going to go mark it as published. That's in a way a command. I only want to know whether that's fulfilled or not, and I'm going to go and set that publish date to a non-null value so that I don't go and publish it again. Now, the integration events there, they go out to the wider world. So I'm getting outside of my blue circle now. They are part of my public contract, like my APIs. Other services can subscribe to these events. They can go and listen to them on the bus. So they're always part of my API. They're part of the public contract. And that's why they're called integration events. They integrate with other services. They're about propagating that state, because the unit of work has already been committed. So one change has happened. Now the next change that happens after that doesn't happen immediately. So it's like a propagator that all these changes flow through these integration events. You could use these to write to an external restore. Remember I said you've got the read stores, which could be your own paint stat collection, but I said you could have a SQL database. Now, obviously you can't have a Mongo and a SQL database all committed atomically within the same transaction. So you could use this to resiliently handle the event changes and then start building up your SQL database that you could query later. That's CQRS with a little bit of event streaming, event sourcing in there. And then outside of that application layer, I'm going to do the final bit now. Nearly there. Pete can go to bed. We've got the infrastructure layer. The infrastructure
Still
layer
a way.
sits outside the application layer, and onion architecture, it goes in. Dependencies go inward. You will probably see it drawn like this, where you've got a presentation and an infrastructure layer. They are the same layer really, but this is the division with the flow of control. Our good friends, the flow of control, the driving adapters in the presentation layer and the driven adapters in the infrastructure layer from our ports and adapters hexagonal architecture. Now, you usually see this if you Googled like onion architecture diagrams, you'd usually find controllers in the presentation layer, and you'd find your database, like we're going right back to start now, database in the infrastructure layer, and you will find external APIs commonly in the infrastructure layer. And here is where I think the flow of control on a diagram breaks down. And I think it stops working here. And I know I've spent like an hour banging on about it, but it breaks down here. External APIs, if you're using DDD, there's this thing called an anti-corruption layer. And this is what I think this external API project is. I might have as an example, an iMoney sender interface in the application layer, which is my port. And it just talks in my own domain language about sending money. But then my external APIs project might make an adapter of my iMoney sender, and it's going to use PayPal, say, to send some money. That project, I'd call it myservice.paypal, is the only project that should understand that PayPal exists, and everything else should be using my own ubiquitous language. So that external APIs project is responsible for translating PayPal's language to mine and back to PayPal's. So when I go and send money with the money sender, it goes and calls it whatever PayPal calls it, but the rest of it just calls it sending money. Now that's going to be a call out, which is fine. It's a driven adapter, but then PayPal are going to send me some webhooks to say that it's done. And that's a call in. The flow of control is now going in. And I wouldn't expect my PayPal webhooks to go right the way around over to my controllers, this way around actually, just because it's an API call. I wouldn't expect it to call my controllers, because my controllers don't know what PayPal is. I want my PayPal project, my anti-corruption layer, to be the thing that understands PayPal. So actually, I'm going to put the controllers in that external APIs project for the webhooks, and PayPal is going to call in back to that project. So the flow of control is going both ways there. So because of that, I'm going to get rid of the flow of control, and I'm going to put the integration events that I was talking about in the presentation layer. Whoa, why have I done that? Integration events in the presentation layer. Well, presentation, I know it's events coming out, and people usually think the event bus is part of the infrastructure and like the back end and not part of your presentation. But your integration events, they're part of your public contracts, and you're going to document them. Just like PayPal documents the API calls on the webhooks they're sending me, I'm going to put my API, my controllers, the things that you can ask my service to do in my documentation alongside the events that I'm going to send out, whether they're going on RabbitMQ, like by a bus, or maybe it's just webhooks or SignalR, something like that. They're events. The flow of control is going out. API, flow control goes in. Events, flow control goes out. But the dependency, the things I'm documenting, the presentation, the things I'm presenting to the wider world is all dependency going in. So when you've got several services involved, the relationship between them is about dependency, not the flow of control. Just like I had PayPal, I've got another service here. External APIs calls into another service, and then that presentation layer, my anti-corruption layer, knows of the presentation layer of another service. So the relationship between microservices is about dependency. And if you stick to this rule, you only have the dependency going one way between two services. You can build your whole microservice. Look at that. Your whole microservices architecture with a flow of dependency. And I can look at this and I can say all of my services on the right-hand side are like my core services that they're depended on, but they don't depend on any other services. There might be some core functionality, whereas the things on the left-hand side may have, well, they depend on my other services in my tech stack. So you end up with a flow of dependency. And again, it doesn't have, remember, shapes don't matter. It doesn't have to go left to right. It can go, maybe you want to draw this diagram with the core services in the middle, like your onion architecture, and put all your other microservices on the outside and everything points inwards. Maybe that would look cool, but it doesn't matter what shape it is. And you can even draw more boxes around that, but no, we're not going to talk about more boxes around that. You have several services within the same namespace. So that's all the information, but I'm going to try one little summary, little 1 minute summary. Now I got this wrong when I practiced it earlier. So the too long didn't listen. In this case, Connell, your talk was too long. From outside, I talked to controllers in the presentation layer, which talk to commands in the application layer, which load aggregates from the domain layer using repositories implemented in the infrastructure layer by a write store. My aggregates consist of entities, value objects, and domain events, which are handled in domain event handlers, either by making more changes or writing to a read store, which can later be queried by resilient jobs, such as publishing integration events, writing to an external read store, or talking to external APIs. Close. That's all I got. Thank you very much. Please do find me on social media. And that's my blog website.
Woohoo!